Welcome to myprojectbazaar.com. Project title: Decentralized Smart Sensor Scheduling for Multiple Target Tracking for Border Surveillance. Let's see the abstract. Wireless microsensor networks have been identified as one of the most important technologies. This system traces the history of research in sensor networks over the past 3 decades, including two important programs of the Defense Advanced Research Projects. Spanning this period, the Distributed Sensor Networks and the Sensor Information Technology programs. Most of the wireless sensor networks consist of static sensors, which can be deployed in a wide environment for monitoring the applications. By performing the data transmission through the multiple hubs become less reliable. The data collection technique is used to collect the aggregate data from the sensor node to the sync node. The main objective of the data collection process is to reduce the delay and improve the network lifetime. Hence, the system designed a mobile collector with distributed optimal movement strategy. Mobile collector is a device equipped with powerful transceiver and a high battery power. It gathers the data in short-range communications. The path of the mobile collector in the sensing field may be random or planned. The mobility of the collector reduces the energy consumption in the network. The mobile sinks, example, data moves, can move around the sensor field and collect information observed at each sensor node. This framework evaluates the network loss probability performance, which requires only local information for collecting data. This process becoming more cost effective in terms of the required size and the required number of mobile collectors to achieve a target loss probability under various scenarios. The simulation result shows that the better performance than the existing random walk mobility strategy. The system performs the enhancement work of the decentralized scheduling. Let's see the flow of our process. First, the network is formed with a number of sensor nodes and the base station. Also, a mobile collector is placed in the network to gather information from the border surveillance. The sensor nodes generate data after an attack is performed by the border surveillance. If the nodes have the data means the mobile collector moves near the nodes and it collects data by updating the position and the information of each and every nodes in the network. If no data generate means it go to the nodes which generates data. After it collecting data from all nodes which have the data to transfer, and finally it transfers to the sync. After that, the performance analysis is processed, in which the existing system is compared with the proposed system with the help of its matrices. Now we are going to see the output terminal of our process. First, open the terminal window, then go to the directory where we have the code, then type ms space filename dot tcl. Now the nodes are created in the network and then the positions and the energy are all updated because the mobile connector have to know about the nodes which all generates data about the border surveillance that have to be transferred to the sync. Hence, it updates the position of each node in the network. After it's completed, we can able to see the output in the network animator window. Now the network animator window opens to see that output. Go to this window and click on the play button. Now the sensor nodes are deployed in the transmission area. The base station is created and the mobile connector is created in the network. The attacker nodes are all come into the network area. So these are all surveyed by the sensor nodes in the network. So these are all the target. Now the mobile connector is starts to move and it collects data from the sensor nodes. The sensor node generates data, it gives it information to the mobile connector. Like that, mobile connector moves on the network area and it collects data from each and every sensor nodes in the network about the surveillance of the target. To see the performance result, back to the terminal window and type GNU plot graph 1.plot. So this is the delay graph in which the number of nodes are varied and calculates its delay. The existing have higher delay, but our proposed system have less delay to packet transmission because of the mobile connector. To see the another graph, GNU plot graph name dot plot. This is the routing overhead. The routing overhead means the same route is used by all the nodes in the network is calculated here. Our proposed mobile connector process have less routing overhead or find out the shortest path to transfer data from sensor nodes to the sync node. That's all. The overall performance is increased than the existing system ensured. The demo is completed. Thank you for watching this video.